We are live. Good evening, everyone. Just make sure everyone can see me and hear me and everything's good. Looks like we're good. Okay, so a little bit more activity in the tropical Atlantic. Oh, before I go, new t-shirt, new type of t-shirt. Got the logo on top. Just got it in today. I wasn't going to push as far as the advertisement of the shirt until I actually had a chance to see it and feel it, and it's very comfortable. Pretty cool logo. So there you go. And I fixed the siren finally. I finally figured out what caused that. So I got rid of it. So that's certainly good. So we had a new t-shirt and we got rid of the siren issue. So now we have the GFS. The GFS came out this afternoon and it spawned 57 emails within 30 minutes of the model guidance coming out saying, is a hurricane really going to hit New England, Long Island, Connecticut, New Jersey? What's going to happen? When I looked at the guidance, I immediately knew that it was bogus. And I'm going to show you why tonight as an education. Not to say that the GFS is always horrible. All right, so it doesn't have the best track record, in my opinion. But if you look at these type of model runs and see automatically, here's the 12Z. 1 second, let me show you that. Okay, so this is the 12Z solution, which of course scared the heck out of everybody. The 18Z solution is already much further east. It's getting closer in line with the European and the Canadian solutions. We'll throw that up. And right here. And that guidance basically has it curving out and then kicking straight out into the Atlantic. So you can learn a lot by these solutions, okay? By understanding what caused the error. Why is this model so different from the other ones? So let's take a look at 500 millibars. And we have to first understand where we're at in this pattern. What is the trigger in this 500 millibar pattern? This is the European guidance. I'm going to scroll through this before I do the analysis. That way you could take a look at all the models. So that's the European. This is the European ensembles. And then we'll take a look at the GFS. This is from 12Z. And I think you're going to be able to pick up the difference real fast. And then this is the GFS ensemble guidance. What is the difference between these models? Well, to find that out, we first have to go to the Pacific. And I'm probably going to butcher this name, but what the heck, we'll give it a shot. This is Typhoon Murabin. I'm probably messing that up big time. But this typhoon, which is right here, is lifting up towards the Bering Sea. And it's about to significantly intensify the trough around the Aleutian Islands. The question is, how is it going to do so? And the past 3-4 days, the model guidance for the 7 to 10 day period has been completely out of whack because of the interaction of this typhoon in the Western Pacific with the trough dynamics, the polar jet stream in the Northern Pacific. So you're getting these different results. But now we're starting to see a consolidation of what we should expect to see happen. And there's strong agreement on the idea of a trough developing in the Bering Sea and down towards the Gulf of Alaska. The difference is that the GFS in this solution, and let's see here, we'll try to pick that up here if I can. The GFS here intensifies the storm to the point that it creates a massive upper level low. So the difference in the model guidance starts off in the Pacific. On the European guidance, it produces a pretty strong upper level low, but generally to the north of the Aleutians. Same thing on the ensemble guidance. Same thing on the GFS ensemble guidance. But on the GFS operational, well, it produces a very powerful upper level low to the south of the Aleutians. Now, the location of this upper level low fundamentally changes the wavelengths of the entire 500 millibar pattern. It enhances this ridge, this trough, and this ridge. It forces this ridge to end up further north. It allows the ridge axis to build further north, which means that it gets to build on top of whatever is trying to develop out here around the Bahamas. The evolution of this ridge also creates a far more favorable environment, which corresponds to the potential of a stronger tropical low pressure system, because now you have a more favorable environment because you have less shear. But in all the other guidance, we'll take the European for example, the upper level low and the trough is not as deep. Therefore, the ridge is not as amplified, the trough here is not as amplified, and your ridge is much flatter, which means that when this trough comes in, it's able to kick this storm out rather than get trapped under a ridge and forced back towards the coast. So the key difference in the forecast is what's more reasonable. Is it more reasonable for an over-amplification and a historically low 500 millibar heights to the south of the Aleutians, or something like the other three model guidance are showing? And more times than not, it's the other three model guidance. Combine that with the fact that the next model run, the correction, I guess you could say, and the GFS at 500 millibars. Again, you never take the specific details of the 18Z GFS, but you could use the overall theme. The overall theme moves away from the amplified solution and goes with one that's much closer to the other model guidance, which is keeping this out in the Atlantic. So this is why you never take a model guidance verbatim. You want to take a look at all the factors involved in it and various ensemble runs. That way you could pick up these errors, separate them out, and then figure out what is actually the guidance saying. So what we learned tonight is that we know what's influencing the 500 millibar pattern, what type of evolution should take place as a result, and how to adjust to the changes that we're going to be monitoring over the next couple of days. So that's where we are with our tropical depression right now. And again, it is a tropical depression. It's tropical depression number 7. It's expected to become a tropical storm probably in the next 6 to 18 hours. But it's running into an awful lot of shear and dry air. It's really not all that impressive at all, to be honest with you. It's producing plenty of convection. But if it reaches tropical storm strength, and it is forecasted to do so, as you can see on the NHC guidance here, it's going to be a weak tropical storm. It's going to have a couple of factors going against it. For one, it's going through the Lesser and Greater Antilles. And this right here, these islands right here, Puerto Rico and Hispaniola, well, they tend to have some very mountainous terrain, which can really disrupt the circulation. So if you're going to see any type of intensification to a strong tropical storm, it's going to have to get to the north of the Bahamas. So that's the first factor. The second factor is that it's going to be running into a lot of shear and still dealing with plenty of dry air. Taking a look at the water vapor satellite picture around this system, here's all the dry air that it's going to be running up against. And there's a lot of dry air, a lot of substance to be contending with. And you can see the different levels of vertical wind shear out ahead of it immediately and then off towards the Bahamas as well. So not exactly the best environment in terms of development either. As far as the pattern overall, let me pull this up real fast. We are going to be moving into a bit of a complicated weather pattern because of what's happening in the northern Pacific. With the evolution of our 500 millibar pattern, at least through Sunday afternoon, absolutely beautiful weather. Tranquil, comfortable. Temperatures in some cases are going to be in the 60s. Look at these 850 millibar temperatures. Very comfortable weather conditions, perfect weather conditions. Leave the window open, get some cool air in. Very comfortable indeed. But then we set up an environment where we're going to be dealing with a backdoor cold front and an impressive clash of air masses. This is all driven by the same trough that we were talking about earlier. This trough is going to build into the Canadian Maritimes, build south, set up a backdoor cold front, and just create significant volatility throughout the region. So what I've done with the forecast is that I've stayed kind of general for the Monday through Thursday period of next week, because it's basically going to be dependent on how this thermal gradient in frontogenesis at various levels of the atmosphere will line up. Now, the 12Z guidance is far more aggressive, pushing the cold front south. The 0Z guidance last night was not as aggressive. Ensembles is kind of in between. So what you have here is a backdoor cold front that begins to stall out. Depending on where it stalls out, to the south and west of that backdoor cold front, you have temperatures in the 80s and even some lower 90s. To the north of it, you're talking about 60s and 70s. A wide range of temperatures. Scattered showers and unsettled conditions. If the trough builds far enough south, like what we're seeing here, go back here, which means that perhaps whatever is developing out here around to the north of the Bahamas is able to enhance this trough, that could push the backdoor cold front and the high pressure system sitting right here further south, and that could lead to a much cooler, drier forecast for later on in the period. But right now, what we're dealing with is just an unsettled condition with a lot of volatility, because if this front is slower than what's being shown here, then what you end up with is a nice thermal gradient over the region. If this transpires by next weekend, we're talking about strong Canadian high pressure and very, very comfortable weather conditions with temperatures back in the 60s and 70s once again. So very interesting weather pattern setting up, dependent on the interaction of various features, the typhoon in the northern Pacific, how that translates to amplification of the 500 millibar pattern overall, and then how that impacts the evolution of our tropical depression in the Atlantic, where it takes that feature, and also how that influences the backdoor cold front for the end of for the middle of next week. So a lot of different factors here to consider. So I figure I'm probably going to get some pretty good questions tonight. So I figure let me go over the basics of what I'm looking at, and then we'll start answering your questions. So we'll start with the premium section first, and then we'll go to Twitter. I mean, should I say YouTube? Yeah, YouTube. And see where we go with that. So again, of course, good evening, everyone. Let's see here. So card X is, if it is a moderate strength tropical storm and goes over the higher terrain of Puerto Rico and Hispaniola, that seems that something could disrupt it so much that it could essentially kill the storm. In theory, yes. I've seen enough tropical systems where the model guidance tries to track it right over the islands, but what happens is that the actual low-level circulation literally kind of feels the terrain and adjusts to the north or south away from the actual forecast of the model from the models. So we have to be wary of that. Warm core low pressure systems tend to have a bit of a mind of their own compared to what the model guidance is saying. And the reason why that is the case is because warm core lows tend to want to move towards the warmest energy around, okay, the best environment around. And they're able to adjust and jump far easier than what you would get with your extratropical low pressure systems. So I've seen plenty of times where the forecast is for a storm to move right over the Dominican Republic and Haiti, and in reality it either moves to the north or south of Haiti or on the north or south coast and maintains its circulation and its structure. So that's something that we certainly have to watch. If it actually ends up to track south on the south side of that island, let me just shift right here. Let me zoom in. If this circulation ends up down here because of what it's feeling, then that would certainly change the forecast quite a bit and lead to a very interesting threat, possibly for the Gulf of Mexico. We wouldn't have our discussion without the ice cream truck coming on in. It's kind of late tonight too, isn't it?
It's been late.
Yeah, they're running late tonight. So that's going to be interesting to watch and see how that takes shape. Take a look at good evening, Judy and Mark. Is this NVEST expected to become Fiona in the coming days? Yes, if it does develop, it would be Fiona. We don't have anything right now that would be Gaston just yet. Can anything change for the NVEST because it's out to sea? Do you think it could ride up the East Coast, and how is winter looking for us? Well, Dylan, that is a loaded question. Let's see here. First of all, you have to assume all options are on the table, but in order for this storm to essentially ride up the coast, so to speak, it has to evolve in such a way. The 500 millibar pattern would have to evolve such a way so that the trough that comes into the East Coast would be more of a negative tilt. And right now, outside of the 12Z GFS, I really don't have any model guidance to support that type of solution. Winter we'll get to in a couple of weeks. I've got a feeling I'm going to get a question from you every week, but trust me, when we get to the winter forecast, I will issue the winter forecast around October 20th or so. Judy asks, is this tropical system setting the stage for what is to come later, creating a path for future storms? I understand the concern for that. I'm not really seeing that potential right now, but we'll keep an eye on it. Let's see here. Good evening, Robert. Hi, Steve. Well, hold it. Mets just hit a home run. There we go. We're making our comeback. There we go. All right. So, going to Cape Cod for 2 weeks. Enjoy, James. Other than the bogus mall run with a hurricane, how's weather looking up here? Any big waves? You know, with these storms developing over the coastal waters, I cannot rule out some enhanced wave heights and some strong rip currents. Definitely for that would be something to watch out, even if these storms stay out in the Atlantic. Right now, again, 2 weeks out, a lot can change in 2 weeks. But right now, I'm not seeing any type of direct hits for New England. I would be very wary of strong cold fronts and severe weather outbreaks. I would be wary of that. Let's see here. Are you feeling the pain as a Met fan like I am feeling? I'm not concerned at all. A little bit of a baseball rant for a very, very short period of time. Does anyone remember the 98 Yankees? One of the best teams you ever saw, right? The 98 Yankees towards the end of the season went on a 2-week period where they couldn't beat the worst teams in the league. They just couldn't do it for some reason. They weren't playing sharp. They weren't hitting. They're having issues with their pitching. Of course, WFAN at the time was saying, oh my God, the team's collapsing, even though they're about to have a 70-game lead. That's what sports radio does. Baseball is a funky sport. I kind of compare it to meteorology in many ways, in that you can have everything lined up just right, but if one thing is wrong, it kind of messes up your whole approach. And then out of nowhere, that one thing clicks, and then before you know it, you're scoring 10 runs. That's why I love baseball, because it literally is a game of inches and centimeters. So, with that said, am I feeling the pain? I don't feel pain with a team that's 35 games over 500 and is pretty much a lock to be in the playoffs. Not to mention the Braves can't seem to get out of their way either. I think the Mets will snap out of it because they've been playing well the whole season and they'll be fine. But unfortunately, we live in a society where you have to have instant gratification all the time and you're expected to win every night. And that just isn't baseball. That's why baseball... Huh? Well, that's not anything. That's true. But that's why baseball is a perfect 19th century game. And in the 2000s, where everyone's expecting instant gratification, it's harder to get into the sport if you're expecting your team to win 162 games. As simple as that. What factors are influencing the track of the Pacific Typhoon, and is there any indication of which one of those may win out? Right now, we're having a trough intensify around Japan, and that's going to be kicking the typhoon up. Beforehand, there was some uncertainty on the timing of that trough. Now we have pretty strong model guidance, a pretty strong model agreement on the evolution of that trough and how it's going to pick up the typhoon. In fact, here, let me show you the model guidance. This is the GFS solution. And let's see here. I think I have the European solution right there, pretty much lined up. And let me see if I can get the current storm. Okay. We have the Canadian solution pretty much lined up. And the GFS solution. So there is pretty strong agreement on all these models on the track of the storm. And it's already transitioning into a next tropical storm. So the confidence is pretty high at this point. After a recent rain, what does the boundary layer look like? That's an excellent question, Chark. Now, as you know, I've been keeping an eye on the low-level boundary layer here, and it's a little bit hard to basically do analysis on it right this minute, mostly because the entire environment's dry, because we have strong dry air transport. Have we seen an improvement? Yes. Has it completely overridden the influence of the drought that we have been in? No. We need several more weeks of rain like what we just saw. With that being said, we are moving into a season with less convective precipitation and more stratospheric precipitation. What that means is that your lifting parameters are changing. So you don't necessarily need that low-level boundary layer to become overwhelmed, because now what you have is more of a photogenical lifting and more of a isotropic lifting. So what that leads to is more widespread light to moderate rainfall events, especially as you move through the fall and the winter, basically the cold season months. So that's going to be less and less of a factor, but we're still going to have to deal with periods of virga. And I'm going to be keeping an eye on that state as we move through fall. Oh, there's the ice cream truck right now. Lovely. As we move through fall, what I'm going to be keeping an eye on is, as these rainfall events move in, how long do we deal with virga before we transition over to a steady rainfall and frozen precipitation event? That's a bit of a wild card, but I don't foresee it being a persistent theme if we continue to shift towards a weather pattern through the fall. Aaron Judge is going to be the first 500 millibar baseball player. I'll tell you one thing, man. The Yankees made a mistake in letting that guy play out and basically prove his own contract. They're going to be paying dearly for that. And they better not let him go off to the Giants, because they'll never live that down. If they go through those rule changes, I am done with baseball. I don't know. I've been watching minor league baseball, and it's actually a pretty good product. I mean, I don't mind a game being 2.5 hours like it used to be around in the late 80s and 90s. Like, you could watch a game and not feel like it's a marathon for the rest of your life. I'm not a big fan of the overtime rules with the ghost runner. Bigger bag, it's not that big of a deal to me. Pitch clock is interesting. Only only if I see how it's enforced. You know, it'd be nice if you're going to have a pitch clock, then guess what? Maybe cut down the commercials too. You know, maybe that'll help. So we'll see. We'll see. I'm going to be open-minded about the rule changes. Great analog on baseball. I'm with you. I think the Mets will be fine. Baseball is a game of ups and downs, which makes the sport so great. Exactly. It's a marathon, not a sprint. So there's a lot of people who just always look for negativity. I don't know why. I'm not a negative person. You know, I'm a meteorologist. I'm a realist. Well, we balance out. That's why, hon. You know me. I'm always the optimist, and you're the pessimist. And then we balance ourselves out, and then we're somewhere in the middle. Because I'm too optimistic sometimes. You know, so. Let's see here. Is a tropical system setting up the stage for... Oh, I already answered that. What is the chances it hits New Jersey? Oh, New Jersey itself... I don't have any data to specifically state that the chance of it hitting New Jersey is very high. You always have to monitor these systems, obviously, but I would say that it's pretty low. When you have a model solution that produces a significant event for the first time, what you want to do is look at three things. Is any other model guidance showing it? What happens in the next model run? Does it continue to support it? And what are the ensembles saying? And then by looking at those three factors, look to see whether or not, like we were just doing, whether or not there's any distinct errors involved in the model guidance. And then you go from there. You're welcome, Judy. Giants shouldn't have won that game, says Quan. Oh, we're talking about football. Okay. Well, I will say this. I have a lot of... Huh? And did you say severe thunderstorm outbreak for us? No, I was talking about New England. With backdoor cold fronts, it's certainly a possibility. So, we'll see. I wouldn't call anything widespread, though. So don't get worried. Don't get too amped up, Dylan. It's not going to be a widespread severe thunderstorm outbreak, but in this type of environment, you can spawn a severe thunderstorm off or two. As far as the Giants, hey, look, sometimes you got to take a risk, and I got to respect the Giants for taking it and going for it. I was thinking they were going to tie it. They went for the 2-point conversion. They won the game, and they deserved it. That's awesome. I'm a Chiefs fan, so I'm just enjoying the season and riding it out. Snow. Indeed, Snow Boss. Snow. Actually, I wrote... No, it's never too... Well, all right. We do have to get through Halloween and stuff. Today, in the long-range thoughts, I did discuss the sea ice extent and what's happening with that. I'm going to be doing that weekly to kind of keep an eye on it. We're at a point where it's stabilizing. That factor is going to be very important for the going forecast for the winter because we're seeing so many different opposing signals in tropical forcing. That is very interesting. Combine that with what's going on with the volcano influence on the stratosphere. There's a lot of interesting data to really go over. I will say this about the winter. If you take a typical La Nina forecast, seasonal forecast, copy and paste it and put it out there, you're going to be in trouble. Because everything I'm looking at for this season, just looking at the summer season, is anything but an atypical La Nina season. From the forcing parameters to the way that the SOI is evolving to the influences on the 500 millibar pattern and the pattern overall, from the tropics to what's happening in the mid-latitudes. This is not an atypical La Nina. And third wave La Ninas typically aren't, if you look at the couple of times it has happened. But you add that in with volcanic influence. And yes, climate change influence. And there's so much. I can make a case right now in my head for a very impressive winter for the eastern United States, not just the interior, but all of the eastern United States, because you can get phasing from the polar and subtropical jet streams. neither one is able to overwhelm each other. You get enough evolution with the stratosphere to support high latitude blocking. You get a sustained negative NAO. Boom. There you go. On the other hand, I do have data. Let me go back to our analytical tools. You see this feature right here? This feature right here usually translates to a positive North Atlantic oscillation. See, what you want is the cold water here, warm water here, cold water here. Okay? And you don't exactly have that. So if I just use sea surface temperatures, this would correlate. This is muted and just a mess. This would support a positive North Atlantic oscillation. But the sea ice would support a negative Arctic oscillation and negative EPO oscillation, which basically means you got a mixed bag. Maybe you get enough blocking here, but the pattern is too progressive on the East Coast and sends everything out into the Atlantic to the east. And so you get a lot of phantom storms and mist storms. So that's just one example of how I can go from one extreme to the other. I can go from a very stormy winter to one where everything is stays suppressed into the south. Right? So that's why I have not put out anything about the winter. I typically don't in August and September. Because even in a regular year, there's so much stuff to work out. This year is even more difficult and even more of a challenge. And if I sound a little giddy inside, it's like, this is a fun challenge. This is going to be great, because this is going to test so many theories. Theories on what happens when you introduce a large amount of water vapor into the upper stratosphere. There are a lot of theories and a lot of computer generations on how that's supposed to influence the stratospheric environment down towards 70 millibars and 100 millibars. We never had that before, so now we literally get to test that theory in real time and combine that with the QBO influence and also a muted weakening La Nina. We never had a combination like that. And then combine that with the lack of sea ice in the Arctic, it leads to some very interesting challenges and questions about the theories that we have. What do they actually, are they actually correct? Are we actually on the right track or not? Card asks, looking at Earth New School. Okay, let's go there first. Do I have that data up? Oh, here it is. Oh, right here. This is the surface. There's our tropical depression, by the way. Looks like the subtropical and polar jet streams are interacting in spots. Also has gotten a lot colder, 850 millibars and 700 millibars. Well, first let's go to 250 millibars. And you can start to see that interaction. And let's knock this down real fast. Yep, you can definitely start to see that interaction starting to take shape here. And notice in this scenario, neither one is overwhelming the other. Typically in La Nina, the polar jet stream overwhelms the subtropical jet stream. And in El Nino, it's the other way around. But when you have a muted system, then you start to basically get more interaction and phasing events. So in stuff like this, you have to watch out for, because this could be a signal. It won't be this time, but it could be a signal for a cutoff upper level low if the rest of the jet stream works out just fine. In this case, it won't, because this jet streak right here is just going to plow everything off to the east. But if this was more of a ridge, if you get a trough here and more of a ridge here, then you could have made a case for an upper level low really cutting off here really nicely. And then at 850 millibars and temperatures, yeah, you can definitely see the growth here starting to take shape for our cold season. And what's interesting is that it's a nice spread over Siberia, but also down into North America as well. Interesting setup. We're going to want to watch and see what happens here. See what we get as far as snow growth. Probably in about a week or two, we'll start monitoring that and see how that's playing out. What do sea surface temperatures look like this week? Well, let's see here. Overall, sea surface temperatures are averaging above normal. They've been doing so. Let's see here. Let's see if I can get closer in. Western Atlantic. Yeah, we're running somewhere around 20, 22 degrees Celsius. So pretty much we're a little warm for this time of year. Any tips for being more optimistic? I had to direct the Phillies pre and post game show for the day of the 7-hour game. We were not happy. Any tips for being more optimistic? Always remember that there are roughly 15 other teams that wish you were in your position to be able to go to the playoffs, right? And in the playoffs, anything can and will happen. And as you know, with being the Phillies, you never have it until the 9th inning, where you could score 7 runs in 1 inning and win the game, right? So never ever lose hope. Okay, off to YouTube. Let's see what we got here. Hello, good night. Good night. Hello, Norman. Yeah, sure. Yeah, probably, yeah. I saw someone post something from the GFS on September 29th. Can you talk about it? We've been talking about it for some time now, for much of this night. That GFS guidance that most likely is all around social media essentially has very little support. Okay, that's basically what we've been talking about tonight, and I've been showing why it doesn't have very good support. While you cannot 100% rule out a solution where you can get a storm tracking up the coast, it's never 0%, but the likelihood of that happening has such weak support in the guidance. It essentially has one model run and everything else is out to sea. So you would go with the majority of the guidance and not, something that's out to sea. And the Yankees scored 3 runs. The Mets need to score about 5 runs. We'll see. It's only the 4th inning. We'll see what happens. Let's see. And so far, there's some really good questions tonight, guys. Absolutely outstanding. Even getting some mentions on Twitter here. There you go. So, I have a question. Let's see here. Isn't that what happened in East Central PA during the winter events? Okay, that's a great question. In terms of Virgo scenarios in East Central Pennsylvania during the winter, a lot of that was not due to dry air at the lower levels. Let me pull up a map here real fast. Okay. I'm just going to go to 0 here. Okay, so a lot of people especially in La Nina years, typically miss out on a lot of events in this area right about here, which is East Central Pennsylvania. Now, why is that the case? Well, typically, especially last year, we had a lot of low pressure systems track towards the Ohio River Valley and then redevelop off to Delmarva or over to Delmarva and then track up the coast. Or you had systems tracking up towards the Great Lakes and then redeveloping off the central New Jersey coast with a nice ice storm here. The process of transferring the strongest lifting from the west of you to the east of you basically leaves a hole, an area of subsidence right here. Now, it's not because of dry air at the lower levels of the atmosphere, but it's because you're essentially missing out on the strongest lifting on the storm coming in. And then when the storm transitions towards the coast, you're too far to the west for the strong lifting on the coast. So you miss out on the best dynamics twice. So what you end up with is a significant precipitation event over western Pennsylvania, a significant precipitation event over the Delaware River Valley to the east coast, but east central Pennsylvania misses out on it completely because you keep on missing out on the strongest lifting parameters. So it's not due to low-level dry air, it's because you're in the wrong place at the wrong time. What you want in your wintertime systems is a Miller A type storm that comes out of the Gulf of Mexico and just marches right up the coast. It doesn't have any type of factors of transitioning energy or anything of that nature. You want an organized storm to the south of you already, lifting northward. So you either want an organized storm off the North Carolina coast with the transitioning already happening and marching northward, or a consolidated storm already on the Gulf Coast lifting northward. You do not want a transition in the Ohio River Valley, because every time you're guaranteed to miss out on most of the event in east central Pennsylvania in one way or another. Okay. Outstanding questions, guys. Outstanding questions this evening. Let's see. Now, the one thing that's always difficult with doing these live chats is when it's so quiet. There isn't a lot going on around here. I mean, in one case, it's pretty nice to just be able to, it's kind of like when you get this type of tranquil weather pattern, it's kind of like a nice little vacation for a meteorologist. But there is literally nothing going on here for the next couple of days. I have been noticing something very interesting, not necessarily connected to our weather impacts right now, but I'm just looking over North America overall, and I'm seeing more and more support for closed off upper level lows. Have you guys noticed this too? A lot more of sustained ridges getting cut off and upper level lows getting cut off, and typically that is a sign as we go into the cold season for more high latitude blocking. But what stands out to me is not so much the fact you get an upper level low form, but how they're forming and where they're forming. And I'm looking at it, I'm like, geez, if this theme continues, we could end up with a lot of unorthodox high latitude blocking regimes that in statistic wise may be considered a negative North Atlantic oscillation or a negative Arctic oscillation, or a positive PNA oscillation, which is a big ridge in the west, but it doesn't produce the same type of textbook influences you would expect. I don't have any concrete data on that yet, but that's kind of the vibe I'm getting as we move into early fall, and I'm looking at how the 500 millibar patterns are developing in this environment here. And again, I'm just kind of looking at the European guides and looking at how this evolution is taking place. Right now, we can't put a lot of stock into location just yet because we have different wavelengths involved. But just the way that the 500 millibar pattern is evolving here, with more of an influence here of below normal heights, more influence of below normal heights here, despite the very warm waters that we're seeing in the northern Atlantic in this area. This should support more sustained ridges, but that ridge is being displaced out here. So it's very interesting to see that, because it's not matching up when you read the research on how these blocking regimes should set up based on the sea surface temperature anomalies and the stratospheric anomalies that are just starting to form. They're not matching up to what you would expect. And I'm not sure whether that's directly connected to the influences of Volcano, the muted version of La Nina, or a combination of both. I don't know yet, but I'm finding it very interesting. I'm trying to figure out, okay, how does that translate as we move to November and beyond? And it's very complicated. I'm uncertain about that, but that's a theme I'm going to be keeping an eye on quite a bit, because I think that's one of the factors that's going to make this forecast for the winter very, very difficult and very interesting at the same time. May I also say, we've had more people come in tonight, and I'm very happy, and thank you for coming and spending a night here with us, and that's really cool. Earth News School shows that going on globally at 250 and 500 millibars. Agreed. Let's see. Why are people talking about severe weather threats for the fall of 2022, October through December, if the weather pattern starts setting up in October through November 10th, 2022? Oh, all right. I can't really comment on what other people are saying because I don't know what they're saying. And it kind of depends on where you're at. In terms of severe weather, you can certainly get severe thunderstorms, like, not necessarily here, but certainly further south, towards the Tennessee River Valley. Really, you can get severe thunderstorms any time, almost all year round. We had one winter storm, I remember back in, 95, where we had heavy snow, and then we had a severe thunderstorm within the same storm. It went from heavy snow in the 30s in the morning. We shot up into the 60s with the warm front, cold front approaching, and we had thunderstorms, and then behind that we had snow flurries. Crazy storm. One of my favorite storms. So yeah, and we had flash flooding too. So you can get severe thunderstorms any time of year, but in terms of severe weather threats, it kind of have to be a little bit more specific in that question. Is anyone tracking underwater volcano eruptions to see if there is a pattern forming that may impact the weather? That's a great question, Judy. There's definitely tracking of undersea volcanoes. Right now, we don't have one that is standing out. The one that happened in February, that started out as an undersea volcano, and you've seen what it's done. Because it was an undersea volcano, it shot up a lot of moisture into the atmosphere, a lot of water vapor, and thus the influence. We do have a lot of active volcanoes that put out sulfur, that put out carbon dioxide, and water vapor, but none of them that are anything that's overwhelming or unusual in terms of influence of what you would expect. The volcano that happened in February, though, that was one that was definitely unusual and had a major impact on. Already, it's having a major impact on the 500 millibar pattern. Let's see. Outstanding question so far. So we've actually gone over quite a bit tonight, and really, broke down a lot of the factors involved here. As we move through, again, one of the things we're going to be keeping an eye on is this trough right here, and how that translates to our 500 millibar pattern. And with that, let me just pull up the 850 millibar temperatures. Pull that up real fast. You can see the potential here of driving that cooler air in. Now we do have some 18Z guidance that's coming out to about 90 hours. So let's see what we can get here. Let's see if there's any changes in the 18Z guidance. We'll zoom out a little bit. North America. And it's pretty much staying with the same idea here. Trough here. Any changes with our precipitation forecast. And so far as keeping our system more of a tropical storm. So I'm not seeing a lot of great change in the 18Z guidance at all either on the European guidance. And the 18Z GFS moved away from the 12Z guidance on the GFS. So the 0Z guidance is going to be very interesting tonight to see where it goes. I would not be surprised if all of the guidance basically mirrors a curve out to sea and a trough kicking everything out into the Atlantic, a positively tilted trough kicking everything out into the Atlantic. Based on everything I'm seeing here, the observations point to that, and the overall model trends would support that. Well, I think we're going to be closing it up for tonight. A lot of great questions, a lot of great data. Thank you again for coming in and checking out the discussion and asking these great questions. Be back here next week, as always, same time, same place. And as always, stay safe out there.